Here's number 5. We have this beam here. Underneath this beam, we have two rollers, roller A and roller B. Above roller B, there's a box. And for A, we need to find the magnitude of the forces exerted by rollers A and B. So we're looking for FA and FB. I'm going to write what I know. I know that the mass of the beam, I'll call M1, is 24 kilograms. I know the mass of the box, I'll call M2, is 6 kilograms. I know the length of this beam is 0.8 meters. And I know that gravity is equal to 9.8 meters per second squared. Now I'm going to say what's positive and what's negative. I'm going to say that up will be positive and down will be negative. I'm going to draw the center of masses of the box and the beam. The box center mass will be in the center of the box. Its force of gravity will go directly downward, and it'll be m2g. Now, the force of gravity of the beam will also go directly downward, but the problem is that that won't pass through either roller A or roller B. So I want to do something a little special. I'm going to pretend that this big beam is actually two smaller beams, each with a mass half of the larger beam. So the center of mass of these smaller beams will now be over rollers A and rollers B, and it'll have a force of gravity of half m1g. So there'll be force of gravity of half m1g on rollers A and B. Rollers A and B will also have a force that goes up, pushing up against the beam. It'll be force of A on this one, and it'll be force of B on this one. I'm going to use static equilibrium and say that F net is equal to 0, and I'm going to add up all the forces in A and equal them to 0. So I'll get FA minus 1 half m1g is equal to 0. So FA is going to equal to 1 half m1g. And that's your answer for A. Now for B, we have m2g and 1 half m1g. So it'll be FB minus m2g minus 1 half m1g is equal to 0. So FB is going to be equal to m2g plus 1 half m1g. And that's your answer for B. Now, to find B of this problem, we're looking for the horizontal distance between the centers of the box and roller B. That puts the beam on the verge of losing contact with roller A. So I'm going to draw this diagram. It'll look like this. This will be roller A. This will be the beam here. And I'm going to divide this beam like it is in the diagram. The box won't move, so it'll still be over this line here. I'm going to draw the center of mass of this box. Its force of gravity is going to go directly down. This will be m2g. And the center of mass of the beam is going to be in the center. This will be m1g. Now we have to decide where roller B is going to be. Well, if we put roller B on the left of these two center masses, then the torques cannot be equal, because both of these torques will rotate this clockwise. If B was to the right of both of these center masses, then it would rotate counterclockwise. So roller B has to be in between both of these center masses, because it's the only way to get the torques to balance. So this is what we're looking for. The distance between this box and roller B, I'll call this x. Since we know this segment here is L over 4, this small section here is going to be L over 4 minus x. So I'm now going to say what's positive. I'm going to say that clockwise will be positive. I'm going to use static equilibrium. I'm going to say that torque net is equal to 0. Torque is equal to force times radius, where r is distance from a pivot. I'll start with m2g, because that's in the positive direction. I'll get m2gx minus, it'll be m1g times L over 4 minus x equal to 0. Now I'm going to distribute m1g to both of these terms. You get m2gx minus m1ga over 4 plus m1gx is equal to 0. Now I'm going to add m1gm to both sides, and you get m2gx plus m1gx is equal to m1gm over 4. The derivatives will cancel, and I'll get m2x plus m1x is equal to m1l over 4. Now I'm going to factor out x, and I'll get x times m2 plus m1 is equal to m1l over 4. So x will be equal to m1l over 4 times m2 plus m1. And that is your final answer. Thank you for watching.